All right, so in this video, we're going to do a little bit of a follow-up after section 13.2. There's nothing in this section that's new, but I really want us to pause to practice some things. You've learned the basic idea behind cosine and sine. If we have an angle in standard position, so we'll draw our x-axis, we'll draw our y-axis, we'll draw our unit circle. By definition, the unit circle is centered at the origin and has a radius of 1. Let's try to make this a little more symmetrical. Here is our angle in standard position. We think about the point on the unit circle that corresponds to the terminal side. Here's my angle theta. And by definition, the x-coordinate of that point is cosine of theta. It basically measures how far to the right the terminal side points. And the y-coordinate is called sine of theta. That measures how far up the terminal side points. So angles are related to directions, and we can use a pair of numbers to sort of talk about how much does this direction go right or left, how much does this direction go up or down. Now, later on, we'll be using calculators so that we can do a ton of different problems involving sine and cosine. But for now, we want to focus on what we can do without a calculator. And that means we're going to keep seeing angles that remind us of angles we've seen in 30, 60, 90 triangles, 45, 45, 90 triangles. So what I'm going to have you do, if you're watching this at home because you missed class, do this on your own. I want you to fill in this table. Right? I have lots and lots of what we will consider nice angles. Nice meaning you should be able to get all these numbers without your calculator. So in this table, I want you to first give a coterminal angle. So for example, if you were doing 60 degrees, you might just want to make a note that, oh, that's actually the same as negative 300 degrees. Because going 60 degrees forward is the same as going 300 degrees backward. Obviously, there are multiple answers you can put in this column. And then figure out what is the corresponding cosine and the corresponding sine. So for example, if we were doing 60 degrees, and you'll notice on both the page before and the page after, I have some examples. So let's do our best to draw something that looks like 60 degrees. Put our angle in standard position. 60 degrees is something like so. We're thinking about the location of this point. Get in the habit of drawing the triangle. So in blue, I'm drawing a triangle. I know that this is a 60-degree angle, so this is a 30-degree angle up here. By definition, the unit circle has a length of 1, a radius of 1. So this hypotenuse is 1. In a 30, 60, 90, this is 1/2. This is short leg. So, sorry, I'm going too fast. The short leg is half the hypotenuse. So if the hypotenuse is literally 1, the short leg is literally 1/2. Then we multiply that by √3 to get the longer leg, and we get this number √3/2. So going to our table, our cosine is 1/2. Could write that as a decimal, it's 0.5. Our sine is √3/2. That's usually how we'll write this number, and it's worth understanding approximately how big that number is. It's about 0.87. If we go back here, the location of this point here, the x-coordinate is 1/2. That seems about right. It's roughly halfway between 0 and the full 1. Our y-coordinate is almost at the very top of the circle. Here's the topmost point of the circle. Here we are. That y-coordinate is very big. You're going to keep seeing the same numbers over and over again. If you file away, oh, I'm almost at the very top of the circle. My y-coordinate is almost 1. The number that creeps up a lot that is almost 1 is √3/2. So go through the work of figuring out this whole table, but as you're doing it, you can start to notice patterns. So for example, if you do 120 degrees, 120 degrees in standard position looks something like so. Here's 120 degrees. That means this is 60 degrees over here, And in this case, maybe you'd wind up drawing a triangle like so. So here in green, I am drawing a triangle. And what you might notice is the 30, 60, 90 triangle that I'm drawing over here. And the 30, 60, 90 triangle that I drew in the previous example are extremely similar, right? They're exactly the same, they're exactly the same size and shape. It's really just a question of where I've put it. We're going to have all the same numbers. This will still be 1. This will still be a length of 1/2. This will still be a length of root 3 over 2. The only difference is now we've gone to the left. So this distance of 1/2 goes left. We have a negative x. The y is the same. So you're not reinventing the wheel every time you do this. You're going to notice, oh, I have a triangle that's very similar to a triangle that I've drawn before. I know what these distances are, and hopefully I can just kind of pop in the values. So for 120 degrees, and you might say that's the same as negative 240, the cosine is negative 1/2, but the sine is this same number. So this may feel tedious at first. You will start to notice patterns. Go and fill in all of them. So if you're doing this on your own because you're absent or you need some reinforcement, hit pause and really do what you need to do to fill these in as much as possible. In a moment, I'm going to quickly fill in the values so that you can compare. So I hope you've paused. I'm going to fill in some values here. These are not unique. So for some of them, I will add 360 degrees. For some, I will subtract 360 degrees. This one would be negative 225, negative 210, negative 180, and I'm going to fill these in very quickly. Here cosine is 1, here cosine is root 3 over 2, which is approximately 0.87. Here this is root 2 over 2, which is approximately 0.71. Here cosine is 0. Here cosine is negative root 2 over 2. Here cosine is negative root 3 over 2. Here cosine is negative 1. This is... I'm just going to silently fill in the rest of these. Don't need an approximate there. And now I'll fill in the sine values. Okay, so we have all these things, and go over your table and see if you can notice some patterns. So I'm just gonna, and for patterns, maybe kind of look at how the value in cosine and the value in sine are related. So a couple things you might notice is whenever you have this number root 2 over 2 in some version, it appears as both sine and cosine. Maybe one's positive and one's negative, but it seems like that's the number that pairs up with itself. And those occur when we have something kind of related to 45 degrees. Maybe it's 45 degrees, maybe it's negative 45 degrees, maybe it's like 45 degrees with an extra 180 or something. But when we have something that kind of feels like it's related to 45 degrees, we're noticing this number root 2 over 2 shows up twice. When we have multiples of 90 degrees, those are our nicest ones. So 0 degrees, 90 degrees, 180, 270. What we'll notice in those cases is one of the numbers is 0. And the other number is either positive 1 or negative 1. So it's like these numbers come in pairs. And then for the things that are more related to 30 or 60 degrees, it's, like 30 degrees more than 90 or less than 90. So all these other ones, 30, 60, 120, which is 90 plus 30, 150, which is 180 minus 30. For all of these, what you'll notice is one of the numbers is either 1/2 or negative 1/2. And it's paired up with a number that's either root 3 over 2 or negative root 3 over 2. If you know that these come in pairs, it can save you some time. So let's just make a note of that. Pairs. Sometimes one of the numbers is 0 and the other is either plus or minus 1. And that's for angles that are kind of like 90 degrees. Sometimes we have that each one of them is some version of root 2 over 2. That's for angles that are like 45 degrees. Or we could have that one of them is 1/2, either positive or negative, and the other is root 3 over 2, either positive or negative. And that occurs for things like 30 degrees and 60 degrees. And keep in mind that this number here is substantially bigger than 1/2. So if you can visualize where something is on the unit circle, you kind of know what to fill in. This is the number that's almost 1 or almost negative 1. So here we can try putting these together all at once. So here we're thinking of all of these terminal sides as like spokes. So here is 30 degrees. And we want to know what are the coordinates of this point right here. So I'm going to put a little comma here. We're going to put in the x and the y. If you remember these come in pairs, that saves you a lot of time. 30 degrees, one of the numbers will be 1/2, one of the numbers will be root 3 over 2. Let's notice that this x coordinate here is almost 1. Here is the very rightmost point of the unit circle. Here we're almost at x equals 1. The number that's almost at x equals 1 is x equals root 3 over 2. Root 3 over 2 is paired with 1/2, and we'll notice that y would be positive in this location. So without fully drawing the triangle, we were able to remember that pattern and fill in those coordinates for cosine and sine. All of the 30 and 60s will use those numbers. Here, for 60 degrees, it's a similar pair. Now I'll notice that this y coordinate is almost 1. So y is this number that's almost 1. X would be 1/2. Over here, y is still almost 1. X is now negative 1/2 because we're going left. For 150 degrees, now we can say that x is almost negative 1. The number that is almost negative 1 is negative root 3 over 2. It would be paired with some version of 1/2. And for our location here, y is positive, because here is our origin. Let's keep going with these other ones related to 30 degrees. 210 degrees sends us over here. Just by thinking about where we are on the unit circle, that x coordinate is almost negative 1. It's paired with some version of 1/2, which would be negative for that location. For 240 degrees, our y coordinate is almost negative 1 because we're almost at the very bottom of the circle. That's paired with something like 1/2, which would be negative in this case. Here for 300 degrees, The y-coordinate is almost at the very bottom. X-coordinate would be 1/2. And here the x-coordinate is almost at the very right. So the y-coordinate would be some version of 1/2, and it's negative there. So without drawing a bunch of triangles, I'm just using that pattern and where these things are on the unit circle to quickly fill in the only numbers that really make sense. For the ones that are left, those 45-degree ones, we know it's this number root 2 over 2 over and over again. We just have to pay attention to whether x and y are positive or negative. Over here, they're both positive. Over here, x is negative, but y is positive. Over here, they're both negative. And over here, x is positive and y is negative. So have this filled in and really keep studying this diagram and its patterns. All of this is very new, but pretty soon I want you to be in a situation where if I ask you something like, what is sine of 150 degrees? You can answer that in like 15 or 20 seconds. The more you can visualize the unit circle and roughly where these degree measures are, the faster you can do this. Because you might look at this problem and maybe just by hand you can draw a really quick unit circle. And you know 150 degrees is almost 180 degrees. Right, 180 degrees is perfectly at the leftmost point, and you're thinking, okay, it's a location like that. I know that that x-coordinate is almost -1, so that's negative root 3 over 2. It's paired with something like 1/2, which would be positive here, so my answer is 1/2. Right, I didn't get that by pure memorization. I didn't just immediately say the answer. But in about 15 seconds, I was able to draw just a decent enough picture to organize my information and to kind of know what makes sense. That's where I want you to be pretty soon. And if you keep practicing and looking at your unit circle, just when I say 135 degrees, can you visualize where that is? Can you notice that 135 degrees is related to 45 degrees so you kind of know what answers you're supposed to get? The more you can do that, the smoother this will be. And it's not just for this class. Having basic cosine and sine values at your fingertips will be helpful in many future math classes. All right, that is it for this video.